Hi Year 9, welcome to the first in a series of 5 videos for the topic of trigonometry. In this first lesson, we're going to learn about labeling the sides of a right-angled triangle. Then we're going to work out the trigonometric ratios, sine, cosine, and tangent. We're going to learn how to use the calculator, and we'll finish off with degrees and minutes. So you've already learnt that the longest side in a right-angled triangle is called the hypotenuse, and it's opposite the right angle. We label the other two sides opposite and adjacent, but they're not fixed like the hypotenuse is. They refer to a specific angle. So suppose the angle is here, then the opposite side is going to be this side, and the adjacent side, that means next to, is going to be this side. Now if the angle is up here, then these two are wrong. Can you see that? That's not adjacent to this angle. In fact, these two will swap. Now recall that the sides of a triangle always take the same letter as its opposite angle. So here we've got triangle ABC, and opposite angle A we have side A. Opposite angle B we have side B, and opposite angle C we have side C. And here's the notation: we write the angle letter as a capital and the side is in lowercase. Okay, let's move on to defining the trig ratios. We're going to start with the tangent ratio, and the shorthand form is just tan. Let's have a look at this diagram. Triangles ABC, ADE, and AFG are similar. Now, hopefully you remember doing some work on similar triangles. This means that the matching angles are equal, and we can see that here. We've got a right angle, and we have a common angle. And because of the angle sum of a triangle, these three angles must also be equal. It also means that the matching sides are in proportion. So we can say that BC over AB must be the same ratio as DE over AD, and also the same as FG over AF. And that is called the tangent ratio. It's the ratio of the opposite side to the adjacent side. And it's going to be the same for all right-angled triangles that have a certain or fixed angle A. Now the sine ratio, which the shorthand is SIN, is very similar. It's just a different ratio. It's the ratio of the opposite side to the hypotenuse. So we can say BC over AC is the same ratio as DE over AE. And it's the same as FG over AG. And then finally, the cosine ratio, or cos for short, is the ratio of the adjacent side to the hypotenuse. So we've got AB over AC is the same as AD over AE is the same as AF over AG. And that was how all three ratios for all angles were calculated. And they were stored into a table like this. So if you wanted to look up sine 25, for instance, you would go to the sine column, go down to 25, and then look up the ratio. And that's the ratio of the opposite side to the hypotenuse of any right-angled triangle with an angle of 25 degrees. Now humans have known about trig tables for many, many years. This tablet here was unearthed in the early 1900s. It's 3,700 years old. It's called Plimpton 322, and it actually has a set of trig tables on it. Now luckily for us, we don't have to look up a set of trig tables. We can use the calculator. It has 3 sets of trig tables stored on it: degrees, radians, and gradients. We're going to use degrees. So it's really important that you have your calculator set on degrees. So let's have a look at how we use the calculator to find sine 52 degrees to 3 significant figures. Now angles are a little bit like time. 1 degree is divided into 60 minutes, and each minute is divided into 60 seconds. And we can use the degrees, minutes, seconds button on the calculator to enter or convert angles. Here it is here. On other calculators, you might see it written as DMS. So let's figure out how we use the calculator to work out tan 32 degrees, 16 minutes. We type tan 32 degrees, 16 minutes, and then press equals. And so to three significant figures, it's 0.631. Now the calculator also allows us to enter a ratio and find the angle. And to do that, all we've got to do is hit Shift. So we go Shift and then press one of these buttons. And that's going to give us inverse sine, inverse cos, or inverse tan. Here's an example. Find theta if cos theta is equal to 0.61. So we want to find theta. We need to move this cos over the other side. It's going to become its opposite operation, which is inverse cos. So we hit Shift and then cos 0.61 and then press equals, and we've got 52 degrees. And finally, you might want to find the angle to the nearest minute. And all you have to do is press the degrees, minutes, and seconds button after you have done the calculation. Same question as last time. So after you press equals, we get 52.410497004. And we just press the degrees, minutes, seconds button. It actually toggles between the two. So we end up with 52 degrees, 24 minutes, 37.79 seconds. So there's our calculator readout. Now remember how I said that degrees and minutes are out of 60. That means that we round up over 30. Let's have a look at that. So we want it to the nearest minute, which is here. So we're going to chop it there. Have a look at the next entry, 37. That is greater than 30, so we're going to round up. So our final answer is going to be 52 degrees and 25 minutes. Okay, that's it for this first lesson. In our next lesson, we're going to learn how to find an unknown side in a right-angled triangle.